Okay, we're on to question 5. And so question 5 is an interesting one. It's from the number strand of the course. We start off here with a recurring decimal question, and then we lead into a proof by induction, and finally a nice little easy question at the end. So we start off here, it's saying x is equal to 0.045 recurring, with the 4 and the 5 both recurring. Prove by using an infinite geometric series or otherwise that x can be written as 1 over 22. So what does it mean? Well, x is equal to 0.045 plus 0.0045. Now, some people get a bit confused with that. How come we added in 2 zeros? Well, if you just think about just adding just those two parts together, what would we have? We'd have 0.045, and that takes care of this guy, this guy, this guy, and then I'm adding on the next 4, 5. So you have to add in 2 zeros each time because the 4 and the 5 are moving 2 places to the right. So what do we have here? It's an infinite, because it's going on forever, geometric series. We'll see why it's geometric now in a second. If I call this guy term 1, he's A. This is term 2. This is term 3. The formula for the geometric series is S infinity is equal to A all over 1 minus R. It's the easiest of all the geometric series formula to use if you know what it is, if you remember it, if you remember where it is. What do we have? Well, A is term 1, R is term 2 divided by term 1. So that's 0.00045 all over 0.045. So that's equal to 0.01. So S infinity then is just the sum, A all over 1 minus 0.01. So you just plug it into the calculator at this stage and you get 1 over 22 for 10 marks. So not too bad. The next part is induction, and I know well that some of you will have just seen the word induction and said, okay, I'm out, because some people will have decided not to study it this year. For those of you who know it a little bit, I would think that some of the induction questions are very easy and are ones well worth preparing for. This is a perfect example. 1 plus 2 plus 3 all the way up to plus n. So there's a finite number of terms of natural numbers. And we're saying the sum of them is equal to n times n plus 1 over 2. What you do for induction. Same steps you're going to do forever and ever. If you do induction in college, you'll do the same steps. Prove it's true for n equals 1. So what do? I put, it's called a base case. Now my left-hand side will just be, the first natural number, which is 1. So my left-hand side is 1. My right-hand side is this part. I'm putting in 1 for n. So 1 times 1 plus 1 over 2, it's equal to 2 over 2, which of course is equal to 1. So for the base case, the lowest possible number, the left-hand side is 1 and the right-hand side is 1. So it's true. Okay. Step 2 is this. I'm going to assume it's true for n equals k. So for the first k terms, 1 plus 2 plus 3, all the way up to plus k is equal to k times k plus 1 over 2. Okay. Here's the good news. I'm on mid-partial credit after getting this far. That's 8 marks out of 15 in this particular case. And what have I done? The hardest bit of maths I've done is 2 divided by 2. So, it's not a bad question in many ways. This is the part where, sometimes people find it a bit more tricky. Prove true for n equals k plus 1. So I'm going to start here. I'm going to work with my left-hand side. And what am I going to say? Well, my left-hand side was this 1 plus 2 plus 3 plus k, with the dot in the middle. That was equal to k times k plus 1 all over 2. And what am I doing? I'm just adding on a k plus 1 to both sides here. So the left-hand side is equal to the right-hand side. I'm going to work with the right-hand side of this part. So I get k times k plus 1 plus 2 times k plus 1 over 2. I multiply it out, tidy it up, and factorize. I get k plus 1 times k plus 2 over 2. Now, it turns out that's my answer. Why is that my answer? Well, because if I look at it like this, up here, when I had assumed it's true for n equals k, I had k on my right-hand side. But now I'm proving it's true for n equals k plus 1. So where I had k, I now have k plus 1. Where I had k plus 1, I now have k plus 1 plus 1, and k plus 1 plus 1 is k plus 2. So I've assumed it's true for n equals k, and I've proven it's true for n equals k plus 1. So now what I've done is I've proven it's true for the base case, which is n equals 1. I've assumed it's true for n equals k and proven it's true for n equals k plus 1. Therefore, it is true for all values of n, all of the natural numbers. Hence or otherwise, find the sum of the first 200 natural numbers. Well, this is a lovely, easy question at the end, because all I'm doing, remember my formula is just n times n plus 1 over 2. So I'm just putting in 200 for n, and I get my answer of 20,100 for 5 marks. And of course, you could have done that without ever doing part B. And it's just that little thing to note that oftentimes in Leaving Cert, the last question in a particular part is often the easiest part. So don't give up on it, or don't think it's, don't assume that it's always going to be the most difficult. Okay, let's move on to question 6.